Hello everyone, you're welcome back to my channel. In today's episode, I'm going to be explaining to you all about dative bond and polarity of molecules. All together. Now, what do you understand by dative bond? Before we start today's class, I would like you, don't forget to click on the subscribe button to help subscribe to my channel, like my video, share with your friends, and then drop a comment for me at the end of the video. Make sure you watch to the end because you will surely love this video. All together, let's continue. Now, when we talk about dative bond, another name given to this bond is otherwise known as the coordinate covalent bond. Coordinate covalent bond. Now, this kind of bond is a bond that is an example of a covalent bond, which also involves sharing of electrons between two atoms. I get something now. But in a coordinate covalent bond is a bond that exists between a molecule altogether that has a lone pair of electron and another molecule or an ion. Are you with me? Another molecule or an ion with an empty orbital. It's a bond that exists between a molecule with a lone pair of electron and then another molecule or ions altogether with an empty orbital. I think this is a greater definition of it. What does that mean? It simply shows it's an example of covalent and also an example of ionic, because in this case it showcases as if one of the molecules is donating its lone pair electron to other molecule that does not have anything in its empty orbital. So this kind of molecule can exist between a molecule and a ion. Let's say, for example, ammonia molecule, for instance. In my previous video, I explained to you that ammonia molecule has two lone pair of electrons altogether. So ammonia can react with what? Hydrogen ion. And hydrogen ion has an empty orbital. It does not. This law showcases that it does not have any electron in its orbital altogether. So this ammonia can easily bond with hydrogen ion by transferring. The kind of bond is done. It transfers all this lone pair of electrons to hydrogen to form to form NH, which is ammonium ion plus 1. This is what? Ammonium ion. Let me say plus only. So which is what? Ammonium ion. It formulates what? Ammonium ion. This kind of bond that is formed between them is what we call coordinate covalent bond or dative bond. Why? In this case here, nitrogen is the one that is donating the shared electron to what? Bond with hydrogen. Are you getting something now? Under this thing is what? The kind of bonding can also exist between what? Two molecules. Between two molecules. One molecule with what? Lone pair and the other molecule with an empty orbital. Let's show, for instance, the bonding that exists between what? Ammonia, and then boron trifluoride. Are you getting me? Boron is having an empty orbital. It has an what? Empty orbital here. So nitrogen in the center atom of ammonia, which is nitrogen, is having a lone pair. So nitrogen tends to donate this thing towards ammonia to boron to formulate this compound. Where I'll be having N, H, then B all together. F3, F, H, and what? H all together. Now, this kind of compound that is formed between two molecules is otherwise known as adducts. So, an adduct is always formed when one molecule with a lone pair is being bonded with another molecule with an empty orbital. Are you getting what I'm saying now? So, a kind of bonding that exists in adduct is also otherwise known as dative or coordinate covalent bonding. And another third thing is that what? This kind of bonding can also exist between what? The complex ion, formation of complex ion. It is the bonding that exists in the formation of complex ion. Let's take a look at what? Hexacyanoferrate 2. Hexacyanoferrate 2. Then I have what? FeCN 6. FeCN6 minus 4 minus. This is hexacyanoferrate 2. Now, the kind of bonding that exists between this here is a bond that exists between, this is transition metals. Transition metals as, are you getting what I'm saying? This transition metal here, they are serving as a lone, they have what? An empty orbital. Like for example now, if ion 2 plus reacted with what? Cyanide. Cyanide, are you getting what I'm saying now? So when ion 2 plus reacted with cyanide, this cyanide, we normally call them what? All the cyanide here, they are normally called, they are known as what? Electron donors. Are you getting what I'm saying now? They are known as electron donors. Now, the reason why they call it, so all these cyanide here, these electron donors are known as ligands. Ligands are electron donors. So when ligands react with what? An empty transition metals. A transition metal with an empty orbital, that's what this 2 plus is donating. They form a complex ion. So hexacyanoferrate 2 is what is formed. This bonding that exists between what? Ion and cyanide ion is otherwise known as coordinate covalent bonding. And this is one of the major important things I want you to know about that. Now, please take note of all this down. Now, another question that is always common in JAM about these coordinates, like for example now, they want to know about how many type of bond can be found in a molecule. How many type of bond can a molecule have? For example now, a molecule of ammonium chloride, what are the number of bonds that is found in this molecule? This molecule consists of 3 types of bond in it. Let me try to showcase it for you. You know, ammonium will always have as a positive, is a radical, positive ion. Ammonium ion and chloride ion. A bond that exists between 2 ions is otherwise known as electrovalent bond. Electrovalent bond or ionic. So ammonium ion will bond with chlorine ion, which is what? Electrovalent bond. Are you getting what I'm saying now? Now, so that's the first bond that exists between them, electrovalent bond. The second bond that exists between them is what? The formation of ammonium ion itself. Ammonium ion is formed using coordinate covalent bond or dative bond. We call it coordinate covalent or what? Dative bond. That is how this one is formulated. That is the bond that exists between what? Ammonia plus what? Hydrogen ion all together. Then the third thing is now the formation of ammonia itself. The formation of ammonia itself is covalence. It's a pure covalent bond. This is a pure covalent bond. Ammonia is formed with what? A pure covalent bond. So the type of bonding that is found in ammonium chloride is what? Ammonium ion, electrovalent bond, dative bond, and pure covalent bonding all together. Before I move on, let me try to take a question on that. I think I saw a question in question 7. We said, which of the following bond exists in crystalline ammonium chloride? A. Ionic and covalent. B. Ionic and coordinate. C. Ionic, covalent and coordinate. D. Covalent, coordinate and metallic. E. Ionic, covalent and metallic. So answer should be ionic, covalent and coordinate bond. These are the 3 types of bond that exist between ammonium chloride. Thank you for banking with me. Thank you for this. Now, let's take a look at the major topic of today, which is the polarity of molecule. A student asked a question about this, that they need understanding about the polarity of molecule. Let me explain it to you here. There's a difference between a polar bond, and what? Polar molecule. Take note of this. Now, a bond might be polar, a bond in a molecule might be polar, while the molecule might not be polar. Polar bond and what? Polar molecule. A molecule might have a polar bond, while the molecule itself is not polar in nature. That means the molecule does not have polarity in it. Are we together? Now, what determines the polar bond? What determines what? Polar molecules. Polar bond is being determined with what? Difference in electronegativity value. The difference in electronegativity value determines what? The polar bond, which I've explained in my previous video. While polar molecule is being determined with what? The symmetric in what? Arrangement of the atom. Symmetric nature. Symmetric. Are you getting now? In the arrangement of the atom. Are you getting? A molecule that has its bond to be symmetric in bond. Are you getting? So a molecule that has a symmetric bond is a non-polar molecule. A molecule with a symmetric bond is a what? Non-polar molecule. While a molecule with a non-symmetric bond is a polar molecule. Now, I know some of you were convinced about that. Let me start with this. Starting from all this, Cl and Cl, all together, when we talk about, okay, let me start with carbon dioxide, for instance. Carbon dioxide, CO2, as is bonding to be like this, oxygen, oxygen. Now, between here and here, this showcases that carbon is attracted to oxygen. Don't forget that in this case, oxygen is highly electronegative than carbon. So the shared electron here will be pulled towards oxygen. Are you getting what I'm saying now? While in this side here, the shared electron will also be pulled towards what? Oxygen. All together. Now, this is one directional pull. This is another directional pull. You see the pull along this direction balance the pull along this direction. Are you getting what I'm saying now? It makes this molecule to be what? Symmetric. Why? Because there is an equal pull in both the right and the left hand side, which makes this molecule to be symmetric. So since this molecule, although normally the bond here is polar, why is it polar? Because we said a polar bond is a bond that exists between two different non-metal. These are different non-metal. So the bond here and here is polar, but what makes this carbon dioxide molecule to be non-polar is because of the symmetric nature of the bond. It is symmetric, so it is non-polar molecule. Altogether. Now, its counterpart, carbon monoxide. Carbon monoxide has what 1, 2, 3 bond. Now, this molecule here, the bond here is polar, and the molecule is also what? Polar. Why? Because the pulling is only along one direction. There is no any pull in the other direction, which leads to what? A non-symmetric bond. Symmetric what? Bond. So the bonding here is non-symmetric. So it makes carbon monoxide to be polar. So simply means it will have what? One-sided positive and one-sided negative. Why? All the electron has been packed towards oxygen due to high electronegativity and is leaving what? Carbon with no electron. Altogether, so this is non-symmetric bond. So because of the non-symmetric nature of the bond, the molecule is polar. Altogether. Now, another molecule that are polar, another way you can get the polarity, non-polar molecule, let's take a look at methane. Methane has hydrogen along this direction. Hydrogen. Now, there is an equal, this is symmetric because hydrogen and carbon here undergo what? So, the electron pull is towards carbon, and here, the electron pull is towards what? Carbon. Are you getting something now? Here towards carbon, here towards what? Carbon. So, the electron pull in the topmost here balance the electron pull in the bottom. The electron pull in the left balance the electron pull in the what? In the right, which makes this molecule to be what? Symmetric in nature. So due to the symmetric nature of this molecule is non-polar. It is symmetric. The same thing applies to tetrachloromethane. Cl. Now there is a pull along this direction, pull here, and pull here. The pull along this direction balance the pull along this direction. The pull here balance this, make this molecule to be what? Symmetric. So because of the symmetry of this bond, the molecule is non-polar molecule. Non-polar. It does not dissolve in water. It should never dissolve in water. Are you getting me? It's a non-polar molecule, but they can dissolve in benzene. Are you getting something now? They are non-polar molecule. Now, look at all these ones are polar. Example of polar molecule and their bond is also polar. Example of molecule that are polar and their bond is polar. Water. Water has a polar molecule because if you take its structure of water, due to this lone pair of due to the lone pair that water has, it only has hydrogen here. Altogether, the shape is like this. So it has one attraction along this direction, another attraction along this direction here. There is no further attraction to balance here. There's no any attraction to balance here. So it makes this molecule to be what? Not non-symmetric. Symmetric. I get something because there is no attraction in other direction, so it is non-symmetric. So this molecule of water is polar. Are you getting what I'm saying now? So it will have one-sided positive, look at, and this one will be what? Negative, which makes it to be polar. The same thing applies to ammonia. Ammonia is not polar. Why? Because of what? Its non-symmetric nature of the molecule. I have nitrogen, bond here, bond here, bond here. Sorry, this is the bond here. So there's no any bond to balance here. There's no bond to balance in this place, and there's no bond to balance in this place. It makes ammonia to be non-symmetric. So because of its non-symmetric nature, it is polar. Ammonia is also what? Polar. So these are great examples of what? Polar molecules and non-polar what? Molecules. So polar molecules, we have one, we have H2O, we have NH3, we have SO3, yes, it's polar molecule. We have CO, is polar molecule. As much as that, they are polar molecule. Now, non-polar molecule, these are non-polar. Non-polar molecule, I think we have majorly all your diatomic gases: hydrogen gas, oxygen gas, chlorine gas, nitrogen gas. All these are non-polar. CO2 is a non-polar. CCl4 is non-polar. They are non-polar. I think I also have, okay, the noble gases are also non-polar. Noble gases, even though they are not what molecule, they are always in form of what atom. So they are all non-polar. Noble gases. Talking about your helium gas, the argon, your neon, all of them, they are what? Non-polar. So you can take note about all this. This is quite easy for you to understand. Are we together? Now let me take a look at a question, then we'll call it a day. Now I think the type of bond that exists between, please, whenever you see any complex ion, anything complex ion, the bonding between them is coordinate covalence. Now, they said the type of bond, hydrogen bond, the type of bonding in this, copper, NH3, 4, or I guess it's now, this is a complex, this is a what? Complex ion. So any complex ion, type of bond, whenever you are seeing something of this scale, we have transition metals. So one of the major properties of transition metals is that they form a complex ion. So whenever you are seeing copper, iron, or any transition metal in a what? In a compound like this, are you getting with an ion? Are you getting it? It is a complex ion. Now, the kind of bond that exists between this complex ion is what? It is coordinate covalent bond. So anything complex ion, they have a coordinate covalent bond. Now, I think I have something there. They said the number of lone pair of electron in water molecule is, I've explained this. Water molecule has 2 lone pairs of electron, which is found in oxygen here. You know, this is the last, this is here. This is here. And then here, hydrogen. Here, hydrogen. So we have these 2 as a lone pair electron. These are 2 bonding pair and 2 lone pair electrons. So water has 2 lone pair of electron. Yeah. So let me give this question that I want to give here. This here, okay, they said when ammonia and hydrogen bond together to form ammonium ion, the bond formed is called what? What kind of bond is that? Ammonia and hydrogen, they bond together to form, no, not hydrogen, it is hydrogen ion, you should know that. Ammonia and hydrogen bond together to form ammonium ion. The bond formed is known as coordinate covalent bond. That should be the answer. Coordinate covalent bond, because it is between a compound and an ion. All together, so which is coordinate covalent bond. Now I think I have a question. I said helium atoms are chemically unreactive because I've explained this before in my previous video. It is because A, there are no electrons around the nucleus. B, the number of protons equal the number of electrons. No. C, there are equal number of protons and neutrons in the nucleus. No. D, the outer electron share is completely filled. That is the answer. The reason why helium or any other noble gases does not undergo chemical reaction is because their outer electron shell is completely filled up with electron. All together, I think that's that. And my last question, but not the least, is this. Okay, there's a neutral atom of neon. Neutral atom of neon with atomic number 10. Neon with atomic number 10. Neutral atom of neon with atomic number 10 have the same number of electrons as the option that is here. We have O2 minus. We have what? Ca2 plus. That's option B. We have what? Option C with potassium plus, and option D with magnesium plus. Now, What they are asking is that what? Which of these is isoelectronic with neon? That means we'll have the same electronic configuration with what? Neon. Now, if you take a look at O2 minus, you know oxygen is having 8 electrons. So when it becomes O2 minus, the electron becomes 10. The electron of oxygen becomes what? 10. Altogether, calcium is having 20 electrons. When it becomes 2 plus, the electron becomes 18. Potassium is 90 electrons. Potassium plus becomes what? 18 also. Magnesium is what? 12 electrons. Magnesium plus becomes 11. So which of them has the same electronic configuration as neon? Neon is having, they are talking about electron of 10, so which is O2 minus. Option is A. It has 10 electrons. Thank you for watching this video. Don't forget to subscribe to my channel and click on the like button to like my video, then share the video with your friend, and don't forget to drop a comment for me. Your comments means a lot to me. Thank you so much. Meeting